All right, folks, we are looking at polar coordinates versus rectangular coordinates. And in my last video, we were just starting to look at converting between rectangular and polar form and got cut off. So this is the next step. After we figured out how is it that you graph polar coordinates, what do they mean, and how can I use different ways of describing the same location in polar coordinates. So that's all in video 1. Video 2, we're going to start here, and we're going to first go back to a picture that I was showing you in video 1. And this is basically two different ways of describing the same point. They both describe that one location. This top one is polar coordinates, and this one is in rectangular coordinates. And understanding this photo, or not photo, understanding this image, this figure, is really what you need in order to understand how to go back and forth between rectangular form and polar form. Everything that I'm going to tell you about going from one to the other really is something you could figure out just by analyzing this particular image. Okay, so let's look at first, what if I have a point in polar form and I want to go to rectangular form? Okay, we have some sort of formulas, I guess you would call them, that we use to do this. And I want to go ahead and tell you the formulas first, but then I want to show you why they are what they are, because honestly, these are things you could come up with yourself. So this means if I'm going from polar to rectangular, I'm starting with r theta, and I want to end up with an x and a y. Okay, so let's go back to this picture and think about how, if I know r and I know theta, how I could find out x and y. Because really x and y are just the horizontal and the vertical components here. Okay? So basically it all comes back to SOHCAHTOA. Remember, SOHCAHTOA is what we use to refer to right triangle trig, really. This is saying the sine is equal to the opposite over the hypotenuse. The cosine is the ratio of adjacent to hypotenuse, and the tangent is the ratio of opposite to adjacent. So if I want to look at, let's say, x, I could recognize that the cosine of theta is adjacent over hypotenuse, so it's x over r. Which means if I want x to be alone, I could multiply both sides by r here, and I'll get x equals r times the cosine of theta. Same goes for y. Y is the opposite side from theta, so if I want to bring y into the mix, I could say, well, the sine of theta is opposite over hypotenuse. So again, if I multiply both sides by r, let's go ahead and show that a little bit, in case you didn't catch what I was doing on the last one. That's the worst r I've ever seen. Not really. I've seen worse. Okay, I'm basically multiplying both sides by r to cancel the r out, and then I have y by itself equals r sine of theta. So these are what we consider little formulas for going from polar coordinates to rectangular coordinates. Okay, so that's what we're going to use. We're going to use x equals r cosine theta, y equals r sine theta. And if you have to memorize them, it's not too hard to memorize them, because remember that on the unit circle, x is the cosine, y is the sine. So there's a relationship there, like a very direct relationship. Okay, so let's suppose I have the point 2 pi over 4, and I want to find the rectangular form of that particular point. Okay, so I'm going to say x is going to equal to, this is r, remember, and this is my theta, so 2 times cosine of pi over 4, and y is going to equal to 2 times sine of pi over 4. Well, cosine of pi over 4 and sine of pi over 4, think about unit circle, are the same thing. They're root 2 over 2. So we have this, and this is going to be square root of 2, and this is going to be square root of 2. And so my rectangular coordinates are just root 2, root 2. Okay, so this is my answer if I'm going from polar coordinates to rectangular coordinates. And by the way, it's really easy to see that you're starting with polar coordinates because of that second coordinate. Otherwise, it might be hard to tell, but you can tell you're starting with polar form if this is either something in radians with a pi, or if you see a degree symbol. Now, if it were a decimal, it might be kind of hard to tell. You might have to read the context and see what's going on. But if you have a pi in your second coordinate, or if you have a degree symbol in your second coordinate, then you're definitely in polar form. So let's try another one. Let's do -5, 2 pi over 3. Okay, so I'm going to do x equals r times cosine of theta. This is my theta, which is -5 times the cosine of 2 pi over 3 on the unit circle. Remember, that's right up here. So that's left -1/2. So that's going to be 5/2 or 2.5. I would probably leave it as a fraction. And then same location, same angle is up root 3 over 2. So sine of 2 pi over 3 is root 3 over 2. And so I get -5 root 3 over 2. So my rectangular coordinates are 5/2 and -5 root 3 over 2. And that's my answer. Okay, now we're going to use that same picture to figure out how to go the other way. Okay, what if I start with the rectangular coordinates? In other words, I have the x and the y, and I need to find the r and the theta. So basically, these we can use to go from polar to rectangular. So let's see how about going the other way. Well, if I know x and y, how would I find r? Well, that's asking if I know the two legs of a right triangle, how do I find the hypotenuse? That's pretty simple. It's called the Pythagorean Theorem. So x squared plus y squared equals r squared. Sometimes you'll see it written as that in your pre-calc book. Sometimes they'll go ahead and say that means that r is the square root of x squared plus y squared. It means the same thing. Either way. Okay. Now what about theta? Well, theta is this angle. If you have to find the missing angle in a right triangle, remember you're going to set it up just the same way you would for anything else that's missing. In other words, you're going to use one of these. And then you're going to have to use an inverse function. So in other words, if I have to find theta and I have y and x, first I'm going to look at those and say, well, that's the opposite and that's the adjacent. Opposite and adjacent goes with tangent. So I can use the fact that the tangent of theta equals y over x. And sometimes we go ahead and solve that and say that means that theta is the inverse tan of y over x. And so here are your two formulas if you need to go from rectangular to polar. And again, if you understand where they come from, it's not a big deal if you forget it, because then you can go back here and figure it out again. And that's true of a lot of formulas. That's why, if you've ever wondered, that's why a lot of times math teachers don't want to give you tricks, because a lot of times the tricks are easier in the short run, but in the long run, if you actually understand what's going on, then you'll be able to come back up with it a year from now when you've completely forgotten the formula. Okay, so this is the wrong page. Next, we just need to practice. Oh, no, we don't. That's fine. We need to practice this, but we already practiced going from polar to rectangular. Let's practice going from rectangular to polar. Okay, so we're going to take a couple of sets of rectangular coordinates and put them into polar form. And remember that we just said we're going to use these guys because this is how they relate. Okay, r is like the hypotenuse of our right triangle, so we find it just using the Pythagorean theorem. and theta is the angle closest to the origin, basically. So you could go ahead and draw a triangle and figure it out that way. In other words, do this and say, okay, this is 5, and so on. But let's go ahead and use those formulas since we just spent so much time coming up with them. So r is the square root of 5 squared plus 5 squared. That's the square root of 25 plus 25, which is 50. And that simplifies as 5 root 2. Okay, theta is the inverse tan of y over x, the inverse tan of 1 in this case. So we need to know, when is the tangent equal to 1? Well, it's equal to 1 a couple of places. Tangent is equal to 1 at pi over 4 and also at 5 pi over 4. So how do I know which one to go to? Well, you got to look at where the coordinates are. 5, 5 is in the first quadrant. So we want the value of inverse tan from the first quadrant. So that's pi over 4. So my my polar coordinates for this same point, those are the same thing. Rectangular coordinates, polar coordinates. All right, next one. We've got negative 3, 4. So r equals square root of negative 3 squared plus 4 squared. Be really careful about how you put negative 3 squared in your calculator. When you square negative 3, you're going to get a positive. If you type it in like this, it won't give you a positive. That's because this means I'm squaring just the 3 and then putting a negative in front of it. Here, I'm squaring negative 3. So that's why I need to put it inside parentheses, the whole thing. And that gives me 9 plus 16 square root of 25, which is 5. Theta, inverse tan of 4 over negative 3. Okay, so I'm going to go ahead and put that in my calculator because that's not one I know off the top of my head. That's not really a unit circle value. So inverse tan, and really we could put the negative anywhere. We just wouldn't want to put 2 negatives on. And we get negative 53.13 degrees. Okay, so negative 53.13, let's go with just 0.1 degrees. Here's the problem. I have to really think about where that's going to be and what it means. First thing I need to think about is where the point negative 3, 4 is. Negative x, positive y, it's in the second quadrant. Okay, so we're saying the tangent, excuse my cat, come on buddy, move it along, is, here's the 4 over 3, opposite over adjacent. For that to be negative, this is going to be negative, which makes sense because 4 is up. Okay, so the negative 53, the negative is just basically saying that your tangent is negative here, because tangent is negative in the second quadrant and the fourth quadrant. The 53 is your reference angle, meaning the 53 is this angle right here. But we want to know the rotational angle starting from 0. So we want to know this angle. So what do I have to do with that 53? I have to subtract it from 180. So 180 minus 53 point, I'm going to go to 1, and I get 126.9 degrees, and that's my location. So my polar coordinates for the point negative 3, 4 are 5, that's my r, and 126.9 for my theta. And there's my answer. All right, thanks so much for watching this. In the next one, I'm going to talk about how to change back and forth between polar and rectangular when we're talking about entire equations, because this is just going back and forth in terms of the coordinates of a point, a single point. But we can also do it with equations. So let's look at that next. Thanks for coming. Hope it helped. See you next time.